Hello everyone, this is Mr. Appel, and today we're going to start our new unit on quadrilaterals. So the first question should be one you already know the answer to. What is a quadrilateral? Well, quad means four, so quadrilateral is just a four-sided figure, a polygon with four sides. That shouldn't be anything new, and neither should be the kind of quadrilateral we're going to focus on today, which is the parallelogram. So my next question is, what is a parallelogram? How would you define a parallelogram? So think about that for a second, and the way we would define it is a quadrilateral, so four sides, and that's what we're talking about here, with both pairs of opposite sides parallel, hence the name parallelogram, right? Both sides are parallel. Both pairs of opposite sides are parallel. Okay, but let's go a little bit further though. So I'd like you to construct a parallelogram. So you can do this on your paper, but I've also included a link to a GeoGebra file that's going to allow you to do what I'm doing here on the screen. So if you want to open up that GeoGebra file and explore using that, you can do it. But you can certainly just use paper and pencil to explore as well. So what I'd like you to do, whether you're using GeoGebra or doing it on paper, is go ahead and do this. Draw your parallelogram or open up the sketch. I want you to measure the angles, measure the sides. I want you to try to see anything, write down anything that you think is true about the sides and the angles in your parallelogram. If you don't have a protractor to actually measure the angles, you can kind of eyeball it and just maybe speculate, maybe draw a few different parallelograms to see if what you think is true of all parallelograms. So you should pause now, and then I'm going to go ahead and do the exploration. You can follow along and see what you came up with and how well it matches up to what I'm going to show you. Okay, so let's go ahead and explore. I've got the GeoGebra sketch open, and you notice that I have the sides of the parallelogram measured here. So what I notice first of all is that the opposite sides seem to be congruent. AB and CD are both 9.1, and AC and BD are both 7.3. So let's see if that seems to always be true. Well, as I drag this around, make it long and skinny, no matter what I seem to do to this parallelogram, those opposite sides seem to be congruent. So that certainly seems to be the case. Well, now let's look at the angles. So I want to show all the angle measures. And so what I see here is I notice a few things. I notice that the opposite angles seem to be congruent. I'm going to make these kind of friendly numbers here so that we can see. I can't quite get it exact. Oh, I should have done this before we started. All right, well, I'm not going to use it exact because it's too hard to do. But you should notice that the opposite angles, so angle B, and angle C, those are both 120.2 in this example, and the other opposite angles are also congruent. And we could also take this a step further. I see that angle C and angle A, if you add those together, they make 180. They're supplementary. Well, this is not really new information because we've got parallel sides cut by a transversal. And what are these two angles? Wait for it. They're same side interior angles. And what do we know about same side interior angles? Yo, 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 same side sup. They're supplementary, of course. So in a parallelogram, we've got yo, 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 same side sup all over the place. So we can describe that as consecutive angles. In other words, two angles in a row as you sort of go around the parallelogram. So angle A and C are supplementary, C and D are supplementary, D and B and A. Any two are supplementary because, again, you've got parallel lines. Okay, I'm going to turn off those angles for a moment, and now let's look at the diagonals. You may remember from early in the year, the very beginning, we talked about what diagonals are, and that's when you simply connect two vertices of a polygon, not two in a row, so not connecting A and C, but any other two. So connecting vertices of a polygon so that it goes through the polygon. So in this quadrilateral, in this parallelogram, AD and BC are the diagonals of that figure. And now let's look at what happens to those diagonals. And what I notice is that the two smaller segments that are formed, so over here CE and BE, they seem to be equal. And I notice that DE and AE also seem to be equal. So I might say that the two diagonals seem to bisect each other. They seem to cut each other into equal parts. And again, no matter what I do, when I move this around, I see those two are equal and those two are equal. Okay, so you may have discovered some other things in addition to what I just showed you, but the major things you need to know about parallelograms, and these are properties of parallelograms. These are things that are true when you know you've got a parallelogram. And if you haven't already done so, you should write these down now. We've got opposite sides congruent. We've got that the opposite angles are congruent. We've got consecutive angles supplementary, yo, yo, yo. And we've got the diagonals bisect each other. And that's all for today.